So someone please remind me what a system of nonlinear equations is. Let's start there today. Stuff that doesn't line up. What do you mean by that? Are you thinking of those words by saying they don't line up? Okay, so what does nonlinear mean? Not a line, right? It's not a line. Well, could there be lines in a nonlinear system? Yes, there could be, but it's not all lines, right? So it could be two parabolas. It could be a parabola and a line. It could be a parabola and a square root function. It could be a rational function and a linear function. The fact is that we have some equations in our system, but they're not all lines. Does that make sense? Okay, so does that help you remember what a nonlinear system is? Okay, so let's go back to this word then. What does it mean to be a system of equations? You can have many equations, right? So it's plural, so that implies that there's more than one, okay? But a system means that those equations do what? They figure out the solution, right? Well, where's the solution to a system of equations? The intersection, okay? Now, the thing about nonlinear equations, or nonlinear systems, excuse me, is how many times can these equations cross? Once? So if we had a parabola and another parabola, they could cross once, right? Like right there, we had two parabolas they could cross once. What if, is there any other way for two parabolas to cross? So if one's this way and one's this way, I could have two solutions? If they were right on top of each other, I could have infinitely many solutions, right? So I can have one or two or infinitely many, is that it? Well, you could have none. I could have one here and then one here, right? It depends on if we're talking about functional parabolas or not. If we're talking about parabolas that open up or down, parabolas that are functions, this is our options. Okay? If we had sideways opening parabolas, then we could get 3 and 4. But today, especially, we're only talking about functions. But that's a good point. Okay? So then, if I say, well, this was just if we had two parabolas, right? Well, what if we had a parabola and a line? How many solutions could we have then? 2 for sure, right? If it went like that. We could have 1 if it went like that. You could have none if it went like that. Right? Could you have 3? What do you think? No, you can't, right? Because the parabola is not going to come back in or it's not going to go back out for it to cross the line again. 2 times is the most it can cross. Okay? But then I told you there's a whole bunch of other options, right? There's not just quadratic and linear. We could have square root. We could have cube root. We could have cubes. We could have rational functions. All sorts of stuff like that. Okay? If we have rational functions, we start with that, don't we? So if I have a line, I could automatically just already have 2 solutions. So imagine if we had 2 rational functions. Lots of different possibilities, right? So what I need you to be able to do, first of all, is recognize what you're working with before we even start working. Okay? Can you look at this system right here and tell me what we're working with? 2 of them, right? 2 parabolas. What about number 2? What are we working with? Okay, woohoo, yay, a parabola and a line. Excellent. Okay. What about number 6? A square root and a line. What about number 9? A line and a rational function. That's exactly right. Okay, a line and a rational function. Look at this, 2 rational functions. Okay, so Recognizing what it looks like so you know what to expect in your mind, what it looks like, that will help some too. Okay? But let's go ahead and talk about solving these. For 1 through 10, 1 through 10 is saying specifically sketch the graph and find the solution by determining the intersection points with our calculator. Okay? With analyze intersection. Okay? So I'm going to start a new document on my calculator after I turn it on, apparently. On. Okay. New document. No, I don't want to save the old one. And I'm starting a graph. So if we're doing number 1 together, what am I putting into my graph? Those equations. Okay, excellent. X squared plus 4x plus 5. And then I'm going to hit tab so I can put the second one in. X squared minus 2x minus 6. Okay, so what do I care about? The intersection, right? First of all, I need to sketch what the graph looks like on my calculator. How careful am I going to be? Pretty darn, right? I'm going to be pretty darn careful. Am I going to worry about getting this exact? Guys, we spent a whole long time when we talked about quadratics, when we talked about graphing, getting these exact. We took care of that exactness already. Okay? Here's what we're going to do this time. If I'm transferring this graph to this paper, I'm going to just be real careful. Is that pretty careful? Is that pretty close? This is a little wonky, so I apologize for that. I could probably have done better. But this is the point that I'm worried about right here, isn't it? So what point is that? Menu, analyze, intersection. Left bound, lower bound, so I put it on the left side. Upper bound, I put it on the right side. What is my solution? Perfect. And then? Yeah, we're done. Bam, what? Okay. Any questions about that? All right, we need to do number 4 together because I got to show you something. Okay? Number 4 is not hard, just like number 1 was not hard, was it? Okay? So I'm just gonna add a new page that's a graph instead of trying to worry about deleting those equations. That takes a little bit long sometimes. X squared plus 6x plus 1. And then tab again and get my fraction for 1/2 x plus 5. So I have a graph that looks like that, right? Now here's what would be really nice. If I go menu, analyze, intersection, if I put this on the left-hand side of this first point and click, and I pull this all the way to the other point, wouldn't that be nice? Yeah, but it doesn't work. It'll show me one point or the other, but not both. See what I'm saying? This point is negative 6.15, 1.92. Menu, analyze, intersection. This point is 0.65, 5.33. I wish it did both of them at the same time. It does not. Just do it again. It's not hard, right? Just like we talked about a minute ago. Okay? So, I know I already asked you this, and I know you already answered, but that should be good because you should remember, right? What's the important parts when we're trying to solve a system of equations graphically? The points of intersection, right? The points of intersection are what our solutions are for a system of equations. Does everybody understand that? Everybody okay with that? Anybody have any questions about that? Because it's really, really important that you understand that when we do problems like number 12. Okay? Because on number 12, what we're trying to do on number 12 is to solve it algebraically. Okay? Number 13, number 14, number 15, all of these, all the rest on this page, we're solving algebraically. Now it says confirm graphically, but what's another thing that it could have said right here? Check it, right? We're going to do our work algebraically, and then we're going to check it with the graph. We're not drawing a graph in this little box right here and graphing it, and that's our answer. Okay? We are solving it algebraically. So, do you mind if I go through problem number 13 with you? Okay? I'm going to zoom in a little bit so it gives us a little bit bigger picture. Okay? This seems a lot to me like number 8 from your homework last night. Is that true? Because it's saying y equals this and y equals this. Well, if y equals both of these, then shouldn't they both equal each other? Right? So the first thing I need to do is I need to say x squared plus 5x minus 8 equals negative x squared plus 2x plus 12. Is that an equation that you know how to solve? Absolutely. We worked on it quite a bit in quadratics, didn't we? So let's go ahead and solve this. So what do I do first? You want to move everything, right? Move everything to one side. You want to get it equal to 0. What side do you want to move it to? Before you answer that, does it matter? No, it does not. So you want to move it to the left side? Okay. If we're moving everything to the left side, first thing we're going to do is add x squared. And we're going to subtract 2x. And we're going to subtract 12. Does that make sense? Because what happens on the right-hand side of the equation then? Well, that's 0, and that's 0, and that... Oh, it's 0. That's so nice. You would have guessed that? Oh, you wouldn't have guessed that? Okay. X squared and x squared. 2x squared. 5x and negative 2x. 3x. Negative 8 and negative 12. Negative 20. What do I do now? Yeah, I need a factor, don't I? I'm sorry I said the F word. You know, it's my second favorite F word. Okay? It's been a while since we factored. We factored a lot in rational functions. We factored a lot in polynomials. We factored a lot in factoring. But it's been at least a week. So is it okay if I remind you of the steps to go through on this problem? Okay? She said a minute ago we ought to do AC and B, right? So A is not 1, so we can't do the shortcut, so we need to just do the regular cut, right? Well, what's A times C? Negative 40. What's B? 3. So what multiplies to be AC and adds to be B? What multiplies to be negative 40 and adds to be 3? Negative 5 and 8? Does anybody agree with her? One person? I agree with her if that makes any difference. So remember, this is the part that we split this middle term into two parts. We say 2x squared because that was there before, but then I write plus 8x minus 5x and then minus 20. Is this coming back to you now? Excellent. Now let's just look at the first two terms, and then we'll just look at the second two terms. Now are you remembering this? Excellent. What's common in just the first two terms? 2 and an x. So let's factor a 2x out of each of these two terms. If I divide each term by 2x, what do I have left? Perfect. Now just look at the second two terms. What do these two terms have in common? A 5, but they also have a negative 5 in common, right? So let's factor out a negative 5, and if I factor out a negative 5, what do I have left? X plus 4. Now, why was it important that I factor out a negative 5 and not just a regular 5? Yeah, I need it to look like this first one, right? Okay. Now, between these two terms, here's the first one and here's the second one, what do these two terms have in common? An x plus 4. So let's factor an x plus 4 out of each term. What's left? Perfect. Now that it's factored, how do I solve? Yeah, I put both factors equal to 0, right? So x plus 4 equals 0. X equals negative 4. 2x minus 5 equals 0. So 2x equals 5, so x equals 2.5. So now I'm done, right? Well, I'm not even to the point where I need to check it yet, am I? What did you tell me a second ago is the solution to a system? What's the solution? It's the intersection, right? More specifically, the point of intersection. If I know the x, is that the point? No, I have to find a y value, don't I? So if I have the x value, how do I find the y value? Plug it in, okay? Well, which one? It doesn't matter, so choose one. Which one would you choose and why? The top one because there's less negatives? That's a perfectly fine reason. Okay? So if I substitute negative 4 into the top equation, I would say y equals negative 4 squared plus 5 times negative 4 minus 8. So I could say negative 4 squared plus 5 times negative 4 minus 8 and get negative 12. I mean, I could have done this in my head. That's 16 and that's negative 20. 16 minus 20 is negative 4. Negative 4 minus 8 is negative 12. It's not a hard thing to do, right? And then what about this one? What about the x equals 2.5? Do I have to do the same thing? Guys, how many solutions are there to this system? How many x values did I get? So possibly 2 solutions, right? So what's my first solution? Negative 4, negative 12. That's the x value that I got. That's the y value that I got when I plugged that x value in. You okay with that? What do I have to do with the 2.5 now? Plug it in again, right? Do I have to choose the other one or can I still choose the top one? I can still choose the top one, can't I? Okay, so y equals 2.5 squared plus 5 times 2.5 minus 8. 2.5 squared plus 5 times 2.5 minus 8. 10.75. So what does that mean? Yes, 2.5 comma 10.75. Are those my 2 points of intersection? Are you positive? You could check it, right? How would we check it? Put it in the graph, okay? So I'm going to add a graph. So I'm going to say x squared plus 5x minus 8. Negative x squared plus 2x plus 12. So first of all, are there 2 solutions? Can you see them? You can't see either one of them, but you know they're there, right? You know this is going to come all the way down to start to come back up, and that's going to cross down there. You know this orange one is coming up and back down, and that green one is going to cross it up there, right? We could zoom out and then go menu, analyze, intersection, couldn't we? Should we? Yes, because that's checking it, right? That's confirming it graphically. Graphically. How about graphically, not graphly? So I'm going to zoom out on my window. And I can, I can't really see that one quite yet. So there. Menu, analyze, intersection. Come over here to here. Oh, look, -4, -12. Oh, look. Yay, yay. Menu, analyze, intersection. There. And there. Oh, we didn't get the same thing. We got, oh my goodness, it rounded it, didn't it? Did we really get the same thing? We did. Yeah, I think we did too. Okay. On the graph, I don't know if you noticed this, but on the graph, the way that our calculators are set up, it's only going to give you 3 numbers. It could be 0.216, it could be 1.34, it could be 10.8 like this one is. It's not going to tell you 10.75 even if it is, because that's 4 numbers. Okay? So, are we confident that this is the right answer? Yes. Okay? Is it possible to get 2 solutions and then there's not really 2 solutions? Yeah, it is. And in fact, you get one like that on your homework. So you need to check them every time. I don't want to make you cry, but I do have Kleenexes just in case. Okay? Would you please circle the following numbers? Number 2, number 3, number 5. Turn the page, please. Please circle number 9. Please circle number 12. And turn the page, please. And please circle 16 and 18. 16 and 18. 1, 2, 3, 4, 5, 6, 7. Yes? Somebody asked me a question about this. Something maybe you didn't understand or something you think somebody else in the room might not understand about either the first part or the second part of the lesson today. Why am I so good at this? Because I've been teaching for 20 years. If I wasn't good at it now, I should quit. You know that I like you to know more than one way to do a problem. Even in life, you need to know more than one way to fix a problem. I need your brain to be flexible enough to be able to figure out different ways to figure out problems. Okay? Plus, my TEKs tell me that I have to teach you graphing and algebraically, just for the record. Okay? I know that one way is easier. I know that graphing is easier. Okay? But I need you to know both ways. Questions? We good? Confident? Excellent.